Hello everyone, this is Saurabh from Edureka, and in today's session we'll focus on Hadoop. So let's move forward and have a look at the agenda for today. Now Hadoop is basically a framework, and obviously it exists for a reason. So we'll understand that reason, which is big data. We'll understand what exactly is big data. Then we'll focus on various growth drivers of big data. We'll see why is it growing so fast nowadays. Then we'll see various applications of big data in different domains. Then we'll see various problems with big data processing and how Hadoop solves those problems. We'll also look at the whole Hadoop ecosystem. Then we'll discuss an Aadhar case study. After that, we'll see Hadoop job trends. And finally, we'll tell you about the big data and Hadoop training provided by Edureka. We'll also discuss few projects that are a part of this course. So I hope I'm clear with the agenda. If you have any questions or doubts, you can ask me, or if you want me to move forward, just give me a thumbs up. Jason says he's clear. So does Emilia, John, Siddharth, Shahid, Rahul, Pooja. Fine, guys. So everyone's clear with this. So let us move forward and understand what exactly is big data. Now, in order to understand big data, let us focus on the definition that is there in front of your screen, which says that big data is the term for collection of data sets so large and complex that it becomes difficult to process using on-hand database system tools or traditional data processing applications. Now, what does this say? It tells you that a data which is very large and complex and cannot be handled by our traditional systems can be considered as big data. This is the simplest definition that I can give you about big data. Now, obviously, there are certain factors on which you can consider data as big data, right? So we'll focus on those factors and we'll move forward. So 5 V's of big data. So basically these V's are nothing but the factors, since all of them starts with V. So we can say that 5 V's of big data. Now this slide basically talks about those 5 V's or 5 matrix on which you can consider data as big data. Let us discuss each of those in detail. So we'll start with volume. Nowadays the data that is generated is huge in size. What is the reason? There can be multiple reasons for it. Your social media, e-commerce websites, then your Internet of Things, many other reasons which we'll discuss later in the session. But the volume of data that we are generating nowadays is very, very huge. Earlier we were dealing with around MBs of data, then GBs of data, then terabytes of data, but now we are dealing with zettabytes of data. So this is how volume is increasing. It is increasing exponentially. Then comes variety. Now this huge amount of data is generated in various formats. It can be an audio file, it can be a video file, an image, a JSON, log, email, anything, right? So basically we have data which is generated in structured, unstructured and semi-structured format. Then comes velocity. Now this complex data which is now generated is generating at a very high pace because of multiple reasons. We'll see those reasons later in the session. Then we talk about value. Basically, whatever big data that you have generated, you need to make sure that it makes certain value. That is, it is of certain value to your organization. It can get you better business insights so that you can help your business to grow. So basically, you need to make sure that whatever data that you have generated makes sense. Then there is one challenge with that, and that brings us to our next V, which is veracity. Now in veracity can be considered as uncertainty or inconsistencies in data. Now we have a data set that is there in front of your screen. So over here, if you can notice, there are certain fields which are empty. And there are certain fields which don't match with the other fields that are present in the same column. Like if you notice in the minimum column, we have values like 4.3, 2.6, and suddenly we have 15,000. So obviously there's some problem with the data set. Because we are dealing with such huge amount of data, certain data packets are bound to get loose in the process, right? And multiple reasons why veracity occurs. So these are all the 5 V's which we have seen. And let me tell you guys, earlier there were only 3 V's, but later on value and veracity was included. Now, maybe we can have multiple V's later on. After some point of time, you might find 6 V's, 7 V's, 8 V's. Who knows exactly, right? So data is increasing. Probably with that, V's will also increase. That's what I feel. So we'll move forward, guys. If you have any questions before that, you can ask me. Please write it down in your chat box and I'll be happy to help you. Any questions still here? So we have discussed what is big data and how we can consider data as big data. We've discussed 5 matrix on which you can do that. So if you have any questions, any doubts, you can ask me. Fine guys, so we have seen the 5 V's plus we have seen what exactly big data is. So it's the time to move forward and understand how exactly big data came from nowhere, right? Nowadays everyone's talking about big data and data is growing so fast. What are the reasons behind all these things? So we'll focus on those reasons. Big data growth drivers. So we'll focus on 3 growth drivers, namely Internet of Things or IoT, then mobile devices and social media. Internet of Things. Now I'm pretty sure you must have heard about IoT. Now let me give you a proper definition of IoT. So IoT is nothing but it connects your physical device with internet just to make your device smarter. Nowadays, if you have noticed, we have self-driving cars, we have smart ACs, TVs, all of these things are nothing but the example of Internet of Things. We'll take the example of self-driving cars and we'll understand how it is generating so much amount of data. Now these self-driving cars have sensors and these sensors record every minute details like the size of the obstacle, the distance from the obstacles and all those things. And based on those data that it collects, it takes the decision. How fast it should go, how much distance should it keep from the obstacle and all those things. So all those decisions are made with the help of data that it gathers from its sensors, cameras, whatever things that it has, right? So it has to first gather that data, analyze it, and on that basis, it can decide how fast it should go and various things it can decide. Now the same goes for air conditioners as well. So nowadays the ACs, the smart ACs that we have, what it does, it'll calculate your body temperature with the help of sensors, and it'll also calculate the outside temperature. And various other factors also it will take into consideration, and then it will decide what should be the temperature of your room. Now, in order to do that, it has to first collect data. From where it is going to collect data, it can collect from internet, it can collect from sensors, from various other sources which we might even not know about. So I don't need to explain much how Internet of Things is generating a huge amount of data. And there's a very interesting fact on your screen. If you can notice, it says 50 billion devices by 2020. So we'll have around 50 billion IoT devices by 2020. So I'm pretty sure there'll be few more V's which will be added later on. So let's move forward and understand how mobile devices can facilitate the growth of data, or you can say big data. So mobile phones. Now before I explain this slide, I need to ask you all guys one question. Go back in time, go back 20 years and tell me how many people in your family had mobile phones at that time? Emilia says no one, so does Siddharth. Alright, same is the case with my family. Same is the case with many families at that time. But now what happens? Now tell me how many people in your family have mobile phones? Yeah, I know almost everyone. Alright, Shahid has a very interesting comment. He's saying, my 10-year-old son has an iPhone. Alright, that's pretty encouraging. Yeah, so you can see the difference, right? People didn't have mobile phones at that time. But nowadays, everyone uses mobile phones. And what sort of mobile phones? Those are not the box mobile phones in which you can just call someone and receive text messages and receive incoming calls. It's not like that. These are smartphones. We have Android phones, we have iOS phones. So basically various other operating systems that are making our life smarter as well as our phone smarter. But in that process, if you notice how much data you are generating, let me give you an example. Earlier you were sending only text messages, right? But nowadays you can even send voice messages, you can even send videos, you can even send images through WhatsApp, through various medium, right? So obviously the data that is now generated with your smartphones or your fancy smartphones is way more than what used to happen earlier. And there's one very interesting stat which if you can see, it says that Cisco forecasts 30.6 exabyte per month of mobile data traffic by 2020, which is huge in size. Right. I don't think so I need to explain much how mobile devices are generating data. If you have any questions or doubts, you can ask me. So there are no questions. So we'll move forward and understand how social media is contributing towards the growth of big data. Social media. So I don't think so I need to tell how much people are addicted to social media websites nowadays. And I'm pretty sure few of you might still be liking some posts on Facebook or sending some messages on Facebook or liking some video on YouTube. Someone might be doing that right now as well who are attending classes. So imagine the data that you're generating. Each picture that you like on Facebook, each picture that you react to, each video that you share generates data. Now, if you go to YouTube, how do you think they know that which video you want to watch next? How do you think that Pandora knows which song you want to listen to? How do you think Netflix knows what kind of movies you prefer? So how do they know? They know with the data that they collect from you. So whatever action that you do on these kind of websites, it is recorded, they collect that data and it is huge, huge in size. And you can see that the number of people using social media is increasing day by day. Earlier, we never had these kind of things. If you can remember, we used to use Yahoo Messenger and things like that, right? But nowadays, it's not the case. We have Facebook, we have YouTube, we have Twitter, we have Instagrams, we have many things, right? Many social media websites. People post everything there. Their stories, whatever they have done in the entire day, they'll be posting that and various other things as well. So yeah, these social media websites are generating huge amount of data. So we have seen what exactly is big data and what are the reasons that facilitates the growth of big data. But the question is it useful? Why are we using big data? So let's move forward and understand where you can use big data. So basically we'll focus on big data applications in various domains. So we have few use cases here. I'm pretty sure you'll find it interesting. The first is banking and finance. So these banks basically use the data that is collected from users or customers in order to use that data which is collected from users or customers for multiple reasons, for maybe fraud detection. So I'll give you one example of fraud detection itself. Suppose if you have made a transaction in New York and after 30 minutes someone has made another transaction with the same ATM card in Berlin. Obviously you cannot go to Berlin in 30 minutes and then withdraw money, right? So there's something wrong. So at that time what these banks do, they'll block your card. How do you think they do that? They do that with the data that they collect from you. They collect your personal details, where are you staying, which is your ATM machine that you use the most, that is the most frequently used ATM machine by you. All those things, all that data it has, all that data is collected by these banks. They use that data for fraud detection and for multiple purposes as well. Even in credit cards. So before giving credit card, they'll first check your history, whether you have any pending debts left or basically anything they can check, right? They have your data. Now the second domain in which big data is very useful is communication, media and entertainment. For communication, what I'll do, I'll open Paint and I'll give you a very interesting example. Alright, so over here what we'll do, we'll first create few circles. Alright, let's keep it this way. And now what I'll do, I'll just try to make a tar. Let's see what I can use in order to do that. Alright. Similarly, we have one tar here as well. Right, fine. So now consider this as one mobile user. Here also we have one mobile user and here also we have one mobile user. Now this mobile user, when it wants to communicate with this particular user, what it does, it'll send a signal here, and after that from here the signal will go here, and then finally it'll reach the customer, or you can say the person he has dialed to. Now these data, it can actually collect all of this data and it can figure out where the signal is not present. If you can notice this particular part, the signal is not there, right? Apart from that, it can even figure out that which stations or which towers are the most busy towers. And it can use that in order to, release some load from that particular tower, or they can build multiple towers as well in that particular location so they can deviate some traffic. So they can help their business to grow actually with the help of big data, by getting very good insights like where the signals are not present, which tower is the busiest tower, and what is the peak time. I mean, at what time people are using mobile phones the most. So all those things it can make use of, and that can help their business to grow. Now I'll go back to my slides once more. I don't want to save it. Yeah, so this was one example of communication. Now when you talk about media and entertainment, how do you think that YouTube knows what video that you want to watch next? How do you think that Pandora knows which song you want to listen to? How do you think that Netflix knows what kind of movies you like? So basically, when you go to these kind of websites, every action that you do generates data. So we'll take the example of e-commerce website. So if you go to a website like Amazon or Flipkart, so over there unknowingly you're generating a lot of data. Let me tell you how. So if you want to buy something, you won't just directly go buy that. You'll search for various products. You'll search, your search history will be stored somewhere. Now obviously when you buy something, then you have to give your personal details. So your personal details will be stored somewhere. And at the same time, there'll be tracking details as well. So where has your package reached, all those things. Then your payment method, how are you paying? How are you paying by card or is it cash on delivery? That sort of details. So everything, I'm just giving a few examples. There are many other ways in which you are generating data on these kind of websites. And what happens, these websites make use of the data, they analyze it, and then they'll give you certain recommendations if you have noticed. Right, so how do you think they do that? They do that just by analyzing the big data. Just by analyzing the data that you have generated on these kind of websites. That is the reason they can analyze it and can recommend you certain products. And they make a lot of money with that, trust me. We'll move forward and focus on some more domains. Alright, so in healthcare, big data is very, very important nowadays. Let me tell you how. We'll take an example. Suppose if I want to predict what is the risk of a person suffering from diabetes, right? So I want to predict the risk. So what I can do, I can go through his medical history, what all diseases he has suffered from, what are his activities, what is his routine. And on that basis, I can perform some analysis and I can get the risk of that guy suffering from diabetes later on as well. Or you can say that if I want to find in a particular area the pattern of diseases among people. So I can analyze that pattern and I can take preventive measures, and at the same time I can take measures in order to cure that particular disease as well. So I'll actually know what kind of disease is common in this particular area. So the newborn babies can actually be prevented from those diseases by taking preventive measures before only. So various ways in which you can make use of big data in healthcare, right? Now comes education. So in education also you can collect the data about various things about your students only, like how are they doing in academics, how are they doing in sports, how are they doing in various other activities, and you can analyze that and you can get to know where the student is suffering, where is the student going down, what is the reason behind it. You can analyze the data and you can come up with very good insights that can help your student as well as your school to grow. So this is how big data can be used in education. If you have any questions, any doubts, or any case studies, or any use case that you want to share, you can do that. Now comes energy and utilities. Now I'll share one very good example here. So earlier what used to happen in your homes, if you have noticed, the meter that monitors your electricity consumption, it generates or it sends data after 30 days, like after every month. But what IBM did, they came up with a smart meter which was actually sending data after every 15 minutes. So whatever electricity usage pattern is there, it'll send that after every 15 minutes. So that generates a huge amount of data. And now what happened with that huge amount of data, or you can say big data, what they did, they performed certain analysis. So before performing that analysis, they came to know that the electricity bill and the pricing were only increasing. But after that big data analysis, what they understood that during peak time, people were using more devices and pricing was high. And during off-peak times, people were using less devices and pricing was low. So what they can do, they can advise their customers or industries in that particular area to use their heavy machinery during off-peak hours, since they can save time and at the same time the load, they can save some money, and at the same time the load will also be less. And they can also advise their users to actually use electricity more in the off-peak times, during the off-peak times, so they can distribute the way they use electricity, right? So they can use their machines in night if it's off-peak time. I'm not really sure if it's off-peak time, right? But yeah, if it's off-peak time, they can use their machineries in night. They can wash their clothes at night with the help of washing machine, or they can use their air conditioners more in night. You can do anything, right, in order to save energy and save money. So this is how IBM used big data analysis in order to get this sort of insight. Now, when I talk about government, so in government sector, you can use big data for multiple purposes. I'll give you one very interesting use case. So you all know about Donald Trump, right? All right, Emilia says he favors the red tech agenda. All right, let's not discuss that. Fine. So you all know Donald Trump. So what Donald Trump did, he started analyzing in what places of states he's popular and in what all places he's not that popular and people don't like him that much. So when he did that analysis, he found out few places where he's very unpopular. So he started campaigning in those areas. He used social media as well in order to perform those campaigns. So he did you can say a sort of sentiment analysis in order to figure out where people like him more and where people are not that much inspired by him. Or you can say people are not that much inspired by him. So he did that analysis and he started campaigning in those areas where he's very unpopular, and you know the result. And finally, you all know the result, right? He won the election. Hillary Clinton lost. So fine, guys. So we have seen few domains. Let's focus on some more domains and understand that. So we have retail in which you can use it. We have banking and finance, media and entertainment, healthcare, education, government, transportation, insurance. Actually, these are very few domains. If you go on and think about the big data applications in various domains, you'll come up with millions of applications. Trust me on that. Big data is nowadays used everywhere. Since I've told you in the beginning as well, if you guys have anything in your mind, you can share that. I'll unmute you and you can discuss that use case of big data. Fine. So I can see that Siddharth is giving us some detail on the chat box. He's writing that I've read an article about Rolls-Royce, how big data analytics help them. Fine. Siddharth, I'll unmute you. Hi, Siddharth. How are you?
Hi, Saurabh. I'm fine. How are you?
I'm doing great. So what is that Rolls-Royce case study that you wanted to discuss?
So Rolls-Royce was not only manufacturing engines for cars, but they were also manufacturing engines for aircrafts as well as ships. So what happened? There were lots of cases of failures. So they thought that they should analyze their big data. So they simulated their system and they started generating data from their engines, and it generated almost approximately terabytes of data while they were simulating it. So what happened at that time? They just analyzed the best scenario and the worst case scenario while analyzing their engines. So then they attached the sensors to their manufacturing machines as well as their engines that they were supplying, so that they could analyze the data at real time, and they could notify their customers when they need the maintenance, or you can say when they need the after sale service. So this saves a lot of lives which we don't realize now. So it helped a lot for Rolls-Royce to become a big company.
All right, fine. So thank you, Siddharth, for sharing your knowledge. So even I have read that article. Thank you, Siddharth, for sharing your knowledge. Basically what Rolls-Royce did, they started simulating their engines for all possible conditions. Now, earlier there were a lot of cases of engine failures, so they analyzed it, and so they noticed that, and they started simulating their engines for all possible conditions. And at the same time, whatever engines that were manufactured, they were keeping sensors in those engines so that they can identify in real time what is the condition of the engine, whether it needs maintenance or not. All those things they started analyzing, and that helped their business to grow a lot, and there were very few engine failures. So I've explained you in very simple words and in the shortest way possible. So this is basically how Rolls-Royce used it. Thank you, Siddharth. Thanks a lot for sharing this very useful information. So we'll move forward, guys, and we'll see what are the various problems that are associated with big data processing. Now, majorly, there are three problems. Let us focus on each of those problems in detail. The first problem is storage. Now, this picture depicts that perfectly. You cannot store an elephant inside a small refrigerator. Same is the case with data. Let me tell you how it is. So the first problem was storing the colossal amount of data. Now, storing this huge data in a traditional system is not at all possible. And the reason is obvious, guys. The storage will be limited for one system. Let me explain you with an example. So if you have a server with a storage limit of 10 terabytes, but your company is growing so fast and data is exponentially increasing. Now, at one point, you will obviously exhaust all of your storage. So investing in huge servers is definitely not a cost-effective solution. And that is where our first problem is storage. Now comes the next problem, that is storing various formats of data. Since we saw that data is not only huge, but it is present in various formats. It can be structured, unstructured, or semi-structured. So you not only need to store this huge data, but you also need to make sure that a system is present to store all these varieties of data generated from various sources. So the next problem is processing this huge amount of data in time. Now, with time, actually what happened, the hard disk capacity has increased, right? But the disk transfer performance, or you can say speed, is not increasing at that rate. Let me explain you this problem with an example. Suppose you have 100 Mbps input-output channel, and you are processing, say, only 1 terabytes of data. Now, how much time will it take? Can anyone tell me that? Just calculate it, guys. So it'll take around 2.91 hours, right? Which is pretty huge. Now imagine instead of 1 TB, you have zettabytes of data. So you can imagine how much time will it take. So you need to process this data in time, right? If I'll take the example of e-commerce websites, so they generate those recommendations, right? By analyzing big data. So if I've bought an iPhone 5s, say now, and after 2 years, they have processed my data and everything, and then they're showing me the recommendation of buying an iPhone 5s cover. So that would make sense. Maybe I've changed my mobile phone. So these are the reasons why you need to process data faster. And these three are the problems with big data processing. Fine, so let's move forward and see how Hadoop solves these problems. So let's discuss Hadoop first, what exactly it is. So basically Hadoop is a framework that allows you to first store big data in a distributed environment so that you can process it parallelly. And now Hadoop has two parts. One is HDFS, which is used for storage. It is nothing but Hadoop, a distributed file system. And another is MapReduce, which is used for processing. And now on the right hand side, if you can notice, it is showing the Hadoop cluster. So this is your master and these are all your slaves. We'll discuss this actually in detail. So you just need to understand that this master actually stores only the metadata about the data which is stored in these slaves. And these slaves actually stores the actual data. Let's move forward and understand how exactly Hadoop has solved it. So these are the ways in which Hadoop solves the big data problems. The first is storing the exponential amount of data. And that problem was solved by HDFS, which is nothing but Hadoop distributed file system. How it has solved it? Basically what happens in HDFS, whatever data that is there, it is stored in a distributed fashion among various nodes. And these nodes are commodity hardware. Let me tell you that we are not using any expensive server here. Now comes the next problem, that is storing various formats of data. That problem was again solved by HDFS because there's no pre-dumping schema validation. When I say that, you can dump any sort of data. It won't check whether the schema is properly defined or not. Then our last problem was processing data faster, which was solved by MapReduce by using parallel processing. Fine guys, so we'll move forward and we'll dig a bit deep in HDFS and understand what exactly it is. HDFS. Now HDFS basically creates an abstraction of resources. Let me simplify it for you. Now similar to virtualization, you can see HDFS logically as a single unit for storing big data. But actually you're storing your data across multiple systems, or you can say in a distributed fashion. So here you have a master-slave topology in which the name node is your master node and these data nodes are your slaves. This name node actually contains the metadata about the data which is stored in these data nodes, like which data block is stored in which data node, where are the replications of the data block kept, etc., etc. And the actual data is stored in these data blocks. I would also like to add one thing here guys. We actually replicate the data blocks that are present in these data nodes. Why do we do that? Let me explain you with an example. Since I've told you earlier as well that these data nodes are not servers, no, these are not expensive servers, these are just the commodity hardware. So the chances of failures of these commodity hardwares is pretty high. Now what happens if one of your data nodes fail? So you don't have any mechanism in order to retrieve the data block that was stored in the data node. So in order to prevent that scenario, what we do, whatever the data block is stored in this data node, for example, will be present in the other data nodes as well. So that if it fails, I can retrieve my data from this particular data node or from this data node as well. And by default, the replication factor is 3, which means that your data block will be replicated thrice and will be stored across various data nodes. So I hope I'm clear here. If you have any questions or doubts, you can ask me. So let me just explain it to you once more in a simple term. So whatever request that comes to the name node, so that data will be actually split into blocks and these blocks will be stored in these data nodes. These data nodes, whatever blocks are stored in these data nodes will be replicated and stored across various data nodes as well, so that if one of my data node fails, I can get that data block from the other data node. This is pretty much the summary of what all things we have discussed in this slide. Fine guys, so there are no questions, so we'll move forward and understand each of these components of HDFS in detail. So we'll start with name node and data node. So let's focus on name node first. So this name node is nothing but a master daemon. And name node is a very highly available server that manages the file system namespace and controls the access to files by clients. Now let us discuss a few functions of name node. Since it is a master daemon, it is responsible to maintain and manage the data nodes. It records the metadata of all the files stored in the cluster, example, the location of the block stored, the size of the files, permissions, hierarchy, etc., etc., etc. There are two files associated with the metadata stored in NameNode. One is called fsimage. Now this fsimage contains the complete state of the file system namespace since the start of the NameNode. When I talk about edit logs, it contains all the recent modifications made to the file system. So I hope you are clear with fsimage and edit logs. So this fsimage contains all the metadata that was stored in the name node since the beginning. And this edit log actually contains whatever recent modifications have been made. Alright, so there are a few other functions as well, like it records each change that take place in the file system metadata. At the same time, it regularly receives the heartbeat and a block report from all the data nodes. This is just to make sure that these data nodes are active or not. It also keeps a record of all the blocks in HDFS and in which node these blocks are located. And let me tell you guys, it is also responsible to take care of the replication factor of all the blocks. We have discussed that in previous slides as well, that each data block that is present in the data nodes will be replicated. So that responsibility is on the name node. So these are all the functions of name nodes. Now let us discuss data node. Now these data nodes are the slave daemons in HDFS, and these are just commodity hardwares which are not expensive at all, but at the same time it is not of high quality or high availability. So that's why we use replications, right? So few functions of data nodes are they store the actual data, and these data nodes perform the low-level read and write requests from the file systems client. So whatever client send the request to the name node, this name node will forward that to the data nodes. At the same time, they send heartbeats to the name node as well. We have discussed it, why data nodes do that, just to tell name node that they're active. This is pretty much the brief summary about the name node and data node. If you have any questions, any doubts in your mind, you can ask me. And let me tell you guys, this is just an introductory session of Hadoop. We'll dig deep into each and every component of Hadoop. We'll understand how to use these different tools, in what sort of scenario these tools can be used, and all those things. You don't need to worry about it. This is just the introductory session to Hadoop. Fine, so we have no questions. So let us understand secondary name node as well. Now, apart from these two daemons that we have discussed, that are name node and data node, there's one more daemon, that is a secondary name node. So the secondary name node works concurrently with the primary name node as a helper daemon. And let me tell you guys, it is a very big misconception among people that this secondary name node is a backup name node. It is not the case. Now let us discuss few functions of the secondary name node. So this secondary name node is one which constantly reads all the files and the metadata from the RAM of the name node, and it writes it into a hard disk of the system. So basically it will read all the file systems and the metadata from the name node, and it will write it in a hard disk. It is also responsible for combining the edit logs and FS image from the name node. We have discussed edit logs and FS image in the previous slide itself when I was talking about name node. So what the secondary name node does is it will take the FS image and the edit logs. So we know that FS image is nothing but it contains all the metadata that was there in the name node since the beginning, and edit logs contains only the recent modifications. So what it does, it will combine both of those and it will create a new FS image and it will send that to the name node. It is also called checkpointing. These are the few functions of secondary name nodes. If you have any questions, any doubts, you can ask me. Fine guys, so we have no questions here. We'll move forward and focus on one more very important component of Hadoop, that is YARN. So the full form of YARN is yet another resource negotiator. Now again, it follows the master-slave topology. We have resource manager and we have node managers. You can consider YARN as the brain of your Hadoop ecosystem. It performs all your processing activities by allocating resources and scheduling tasks. And we have discussed that it has two major components, resource manager and node manager. Now this resource manager is again a main node in the processing department. It receives the processing requests from the clients and then passes the parts of the request to corresponding node managers accordingly, where the actual processing takes place. So the actual processing takes place in the node managers. And these node managers are installed on every data node and is responsible for the execution of tasks on every single data node. So basically one thing to keep in mind here guys is this node manager must be configured on the same machine where your data node is present. But this resource manager can be or cannot be present on the same machine where your name node is present. You know the reason why name node should be present in the same machine as data node, because it has to process that data. And where is that data present? In the data node. So both of them should be in the same machine. So fine guys, we have understood YARN. I've given you a brief introduction to YARN. So you might be thinking like, are these only the things present in YARN? There are many, many more things guys. In Hadoop, Hadoop is huge. So you don't need to worry about this. This is just an introductory session. I'm again and again telling you that, but it is just an introductory session to Hadoop. We'll dig deep into all of these components in our upcoming sessions. So there'll be separate module on each of these tools. Fine, so we'll move forward, or if you have any questions, you can ask me, or I can move forward if you can give me a thumbs up. Fine, Jason says he's fine, so does Emilia. Siddharth, fine. Now comes MapReduce. Now let us focus on the definition that is there in your screen. So MapReduce, as I've told you earlier, is well used for parallel processing. Now let us see what this slide tells us. It tells us that it is a software framework which helps in writing applications that process large data sets using distributed and parallel algorithms inside the Hadoop environment. Now let me explain you this with the flow diagram that is in front of your screen. Now let me explain you this with the diagram that is there. So there are two phases guys, one is map phase and another is reduce phase. Now what happens, your input data will actually be divided and will be sent to these mappers. What these mappers will do, they will create the key value pairs. They will create the intermediate outputs also, you can say. So they will basically create these key value pairs. And what sort of functions they can perform? They can perform functions like filtering, grouping, sorting, things like that. And then what happens? This reduce function aggregates and summarizes the result produced by the map functions. The result that is generated by the map function are the key value pairs, as I've told you earlier as well, which acts as the input to this reduce phase. And finally, we get the aggregated output. So this is how MapReduce works. So one very important concept that you should understand here is we are moving process to data, not data to processing. Let me tell you how. So this is nothing but a logic, right? And we move this logic to the data nodes where your actual data is present. So at your data nodes only the processing is happening. But it wouldn't be actually distributed if I send that data to a particular location and then send the logic also there and then process it, right? So that will actually fail the very idea of distributed processing. So that is why I'm saying that we move process to data, not data to process, because whatever the logic is required to process data, that data will be sent to the data nodes, right, where the data is stored. Not the data will go from data nodes to that process. I hope you have understood my point. You can ask me any questions if you have. Any questions, guys? Any questions? So now enough with the theoretical concepts, guys. Now what I'll do, I'll open my virtual machine. I have a CentOS virtual machine with me and I've already installed Hadoop in that. Now again, you don't need to worry about it. There'll be a separate session on how to install Hadoop. So what I'll do, I'll open that virtual machine and I'll show you how Hadoop looks like, how HDFS looks like, how does NameNode UI looks like, Datanode UI looks like, all those things. I'll show it to you now. So let me open my CentOS virtual machine first. Fine guys, so this is my CentOS virtual machine where I have Hadoop installed. So what I'll do, I'll just hit a sudo jps command which will give me all the daemons running on my system. So let us go do that, and here we go. Let me just type the password. So these are all the daemons running on my system. I have resource manager, job history server, node manager, data node, name node. Let me clear my terminal, guys, and now what I'm going to do is I'm going to show you the web UI of HDFS. So guys, this is how the NameNode UI looks like. So it has all the details about NameNode. For example, when was it started, what is its version, compile, cluster ID, all those things. And when we go down, it will give the cluster summary as well. For example, we have configuration capacity, which is around 17.23 GB, plus we have distributed file system use is 1.88 MB. Similarly, non-distributed file system use is 7.51 GB. Distributed file system remaining is 9.72 GB. The percentage used is around 0.01% and percentage remaining is 56.40%. Similarly, we have backpool use in percentage, data node usage. Here we have live nodes, so we have one live node, dead nodes 0, decommissioned nodes 0. Similarly, when you go down, you can see all the other details of name node, so you can just go through it. It is pretty self-explanatory. So when we'll discuss HDFS in detail, like the module which is regarding HDFS, we'll discuss all these things, so you don't need to worry about it. I'm just giving you an introduction how it looks like. Now when I go up, I can actually click on browse the file system, and when I click over here, what you can see is, since the data is stored in a distributed fashion among the various data nodes, but still it looks like a single logical unit, right? So this is how HDFS looks like. Now over here, it contains the name of your data set. Whatever data you have dumped into your HDFS, it will be there. What is the type, what is the size, application, block size, modification type, permission, owner group, all these details about your data set is stored here. So I have like these many data sets that I've uploaded in my HDFS. When I go down, it'll give me local logs directory as well. So you can just go through it, you can just play around with it and you'll get to know a lot of things. Fine. So this is how the user interface of HDFS looks like. Now I'll show you where my Hadoop is installed in what all files. So I'll open that. And this is where Hadoop is installed. So when I click on etc directory here, we have the configurations for Hadoop. So when I go to this particular file, you can see all the configurations for Hadoop. Now let me close this and show you one more directory. And I'll show you the sbin directory. Now this directory basically contains the scripts in order to start and stop a particular service in Hadoop. Let me close this one once more and I'll show you one more directory, which is share directory. And over here, when I go to Hadoop and I click on MapReduce, so you can find all the MapReduce jars and we import them when we are actually writing a MapReduce program. So you don't need to worry about anything. All these things will be discussed in the upcoming sessions. So everything will be discussed. You don't need to worry about it. I'm just giving you an introduction. Alright, fine guys, so we have seen how the HDFS looks like, what are the daemons running in my system, where Hadoop is installed. Now is the time to focus on various other tools in Hadoop. We'll basically focus on the whole Hadoop ecosystem. I'll just give you an overview of what exactly it is. So let me go to my slides once more. Hadoop ecosystem. So this is how it looks like. So these Flume and Scoop are used in order to ingest data in HDFS, and we all know what exactly HDFS is. Similarly, we know what is Yarn. Apart from these two components, there is one more component called MapReduce, which we have discussed, which is used for parallel processing. Now we have various other analytics tools as well. For example, we have Hive as well as Pig. Now, whatever code you write in MapReduce in 200 lines, you can actually do that in 20 lines using Pig Latin, which is the scripting language used for this particular tool, that is Pig. Similarly for Hive also, let me tell you a very interesting story about Hive. So basically, Facebook developed Hive and it donated to Apache. So they used Hive in order to analyze big data, and they wanted to make sure that they don't need to hire people in order to use this particular tool. So this is very much similar to SQL, and it uses a Hive query language, which is very, very similar to SQL. So they don't need to hire more people. They can just use the people who know SQL, and they can perform big data analytics using Hive. Now, similarly for machine learning, we have Mahout and Spark MLlib. Now we have Spark as well. Now we have one more component called Spark. Now this is actually used in order to perform near real-time or real-time processing. So you can integrate it with Hadoop and do that. Now we have one more component called HBase. Now this Apache HBase is nothing but a NoSQL database on top of our Hadoop distributed file systems. Now the question is, do we need to use all these tools? No. The question is straight away no. What happens is, whatever your requirements are there, accordingly you can decide what all tools can help you. For example, I might not need Pig, I can use MapReduce, or I don't need MapReduce, I can use just Pig. Similarly, you can think of what all tools will be helpful in your analysis, your requirements, your business needs. So you can think of all those things and you can accumulate few components together and fulfill your goal. So this is the whole Hadoop ecosystem, and we're actually going to discuss each and every tool in detail in our upcoming session. So you don't need to worry about it at all. So we have seen the whole Hadoop ecosystem, how it looks like. Now let us move forward and focus on a case study of Aadhar card. Now what is Aadhar card? Aadhar card is basically a unique identification number given to people across India. Now with that identification number, government can get their details, for example, their name, address, and at the same time it is generating a lot of unstructured data as well, because it contains their fingerprints as well as their iris recognition and things like that. So there's a huge amount of data that is generated with the help of Aadhar card. Government wanted to utilize that data. So there are certain stats in front of your screen which says that Aadhar is the world's largest biometric ID system with over 1.133 billion enrolled members as of 31st March 2017. So you can imagine the amount of data that is generated because of Aadhar card. Now let us move forward and see how the data set looks like. So we have collected the data for 1 month, and for every state, city-wise, we know how many Aadhar cards have been approved and how many Aadhar cards have been rejected. So we have actually cleaned this data set before only. This is how it looks like. So what is our first step? We need to first dump this data in our HDFS. Now for that, again, I'm going to open my CentOS virtual machine. So guys, this is my CentOS virtual machine. So what I'll do, I'll first open my terminal and let me clear it now. So guys, this is my terminal. The first thing that I need to do is dump my data set in an HDFS. For that, I'll type in here Hadoop FS-put and the path to my data set. So it is present in downloads. So in that downloads directory, the name of my file is Aadhar. So I'll just type in that Aadhar, and then where I want to store it. So I'll just store it in the root directory. Let us keep it that way. Now, when I hit enter, it will dump my data in HDFS. Let us see if that happens or not. So it has successfully done that. So what I'll do, I'll open my user interface for HDFS so that you can see that the data has been uploaded. So when I just refresh this page, so over here you can see that Aadhar dataset is uploaded. Now let me go back to my terminal once more, and I'll clear this terminal now. So we have seen how to dump data in HDFS. Now what I'll do, I'll open my slides once more. Now after that, we need to analyze this data. So we have this data set, so we need to analyze it. So there are certain problems that we need to solve. Let us have a look at those problems. So the first question is, find out the total number of cards approved by states. So we need to find out the approved Aadhar cards state-wise. For that, what I'm going to do, I'm going to make use of Pig. And Pig uses Pig Latin scripting language. Let me tell you guys, one Pig Latin command is equals to 20 lines of MapReduce code. And when you execute that command, so the compiler will first convert that to a MapReduce program, and then it will execute that. Let me show you how it happens. So I'll again open my CentOS virtual machine. So guys, this is my CentOS virtual machine, and over here what I need to do is I need to find out the total number of cards approved by states. For that, I'm going to use Pig Latin. Let me first enter into Pig Grunt, which is nothing but a shell where you can execute Pig commands. Now I'm going to hit enter and it'll open Pig Grunt for me. So it has done that. Let me first clear my terminal, and yeah. So this is where I can actually use my Pig commands. First thing I'm going to do is define a variable cards in which I'm going to load my data set. So I'll just type in here load and the paths to my data set. So it is present in the root directory itself. So I'll just type in here /Aadhar, then and close the single quotes. After that, type in as, and then I'm going to define a schema for my data set. So I'll just type in here state, and it will be a char array. Then I'll have cities, so I'll just type in here city, and that will again be a character array. Then I'll type in all the approved Aadhar cards. Just type in here approved, and it will be an integer value. Similarly for rejected applications, I'll just type in here rejected, and it'll be integer again. Close the parenthesis, give a semicolon, that's all. So you don't need to worry about these pig commands. We'll actually discuss that when we talk about pig in the upcoming sessions. So I'm just giving you an overview. So let me hit enter now and see what happens. Now let me again clear my terminal. So now our next step is to group the data set that we have on the basis of states. So for that, I'm going to type in here state underscore grouped, which is nothing but a variable that I've defined. And in that, I'm going to type in group cards by state and a semicolon. So basically what I'm doing here, this cards variable contains my data set, and I'm going to group that data set on the basis of state. So what that means, so if I have like 9 cities in a particular state, so I'm going to group them together so that later on I can find out the total number of accepted Aadhar cards state-wise. Let us hit enter now. So our next step is to add these approved Aadhar cards state-wise. So for that, I'm going to type in state underscore count, which is one more variable, and over here I'm going to type in for each state underscore grouped generate group comma sum cards dot approved and a semicolon. Now let us hit enter now. Alright, fine. Now I need to store this output somewhere, so for that I'll type in store state underscore count. So the path that where you want to store, so I'll just store it in analysis, and yeah, close the quotation and a semicolon. Hit enter now. So basically, as I've told you earlier as well, the compiler will convert these pig Latin commands into MapReduce, and then it is going to continue with the process. So guys, it has executed successfully. Now there are certain details that are present here. For example, the job ID, maps, and maximum map time, minimum map time, average map time, median map time, max reduce time. So all these things we're actually going to discuss it when we have a separate session on pig. So for right now, you don't need to focus much on these things. I'll just show you the output. I'll open my user interface and I'll show it to you there. So I'll go to this NameNode user interface. So this is my HDFS user interface. So I'm just going to reload it once, and so over here, if you can notice, we have this file name called analysis, which is nothing but the name that we have given to the output. Let us click over there and see the output. Now here we have two parts. One is success at part R. So we'll click on this part R and it'll display the output. So this is how our output looks like. So in Goa, we have 30 Aadhar cards that have been approved in 1 month. In Assam, we have 832. Bihar, we have these many. Delhi, we have these many. Similarly for other states as well. For Rajasthan also, we have around 30,077 Aadhar cards approved, and similarly for other states as well. So you can just have a look at the output. Now I'll open my slides once more and we'll see the other problem statements. So we have successfully found how many number of cards approved by state. Now let us move forward and focus on the next problem, which is find out the total number of cards rejected by states. So for that, again, I'm going to open my virtual machine, and yeah, this is my virtual machine again. I'll go to my terminal. Let me clear all this. Yeah. Fine guys, so our next problem is we need to find out the total number of cards rejected by states. So for that, I'm again going to make use of that state underscore count variable. And over here, I'll type in for each state underscore grouped generate group comma sum cards dot rejected, close the parenthesis, semicolon. So what I'm doing here is I'm calculating the sum of the total number of rejected applications of Aadhar card state-wise. So I'm just going to hit enter now. Fine, so let me clear my terminal once again. And our next step is to actually store this output somewhere. So I'll just type in here store state underscore count into and give the path. So I'll just store it in a file called rejected -1 and close the single quotes and a semicolon. Hit enter now. So it is successful now. Let me clear my terminal and I'm going to show you the output in the HDFS user interface. So let me just go back. I'm going to refresh this and we'll see rejected underscore 1 is the file where the output is stored. If you can recall, this is the name that we have given. So I'll just click on it and we can see the output in part R. So this is how the output looks like. So in Goa we have 7, Assam we have 3 rejected applications. Similarly for other states as well. So you can go through it. So this is how the output looks like. So now what I'm going to do, I'm going to open my presentation once more and we are going to focus on the next problem statement. So we have successfully found the total number of cards rejected by states. Now the next problem is to find the total number of cards approved by cities. For that, again, I'm going to use PIC. Let me open my virtual machine again. So this is my CentOS virtual machine, guys. And the first thing that I need to do is to group the data set on the basis of cities. So how am I going to do that? I'm going to define a variable called city underscore grouped and group. And if you can recall, the data is stored in the variable called cards by city and hit a semicolon after that. And here we go. Let me clear my terminal again. So now what I need to do is I need to find out the sum of all the Aadhar card applications approved city-wise. For that, I'm going to define a variable called city underscore count. It is equal to for each city underscore grouped generate group comma sum cards dot approve. Close the parenthesis, give a semicolon, and here we go. Finally, I need to store it somewhere. So for that, I'll type in here store city underscore count into the name of the file. So I'll give it as accepted and give a semicolon, and here we go. So guys, we have done this successfully. Let me clear my terminal and I'm again going to show it to you in the UI how our output looks like. I'll go back, reload this page, and yep, so we have this accepted file created, which is nothing but our output, and this is how it looks like. So the total number of Aadhar card applications accepted city-wise is present here. So for Diu we have 42, for Leh we have only 1, for Agra we have these many, for Doda we have 93. Similarly, when you go down, you can find the list of all the cities. So this is how our output looks like. Now again, I'm going to open my slide and I'm going to focus on our last problem statement. So we have found the total number of cards approved by the cities. Our next problem is to find out the total number of cards rejected by cities. For that, again, I'm going to open the virtual machine. So over here, I need to find out the total number of Aadhar card applications rejected city-wise. For that, I'm going to make use of that city underscore count variable again, and I'm going to type in here for each city underscore grouped generate group comma sum cards dot rejected, close the parenthesis, give a semicolon, hit enter. Now let me clear my terminal and now I'm going to store the output in some files. For that, I'm going to type in store city underscore count into the name of the file. So I can give the name as city underscore rejected, close the quotations and give a semicolon, hit enter. So we have executed this successfully. Let me clear my terminal again and I'm going to show you the output in the user interface. Let me go back first, reload this particular page, and on the left hand side you can see that there is a file created called city_rejected, which is nothing but the name of the file that we have given. When you click on this part R, it will display the output. So in Due there are 2 applications which are rejected. Similarly for other cities as well. For Agra there are around 492. So you can have a look at all these cities. So this is our analysis. Now let me go to my slides once more. So we have actually executed this Aadhar case study successfully. We first found the total number of cards approved by states. Then we found the total number of cards rejected by states. And similarly, we did the same analysis city-wise as well. So let us move forward, guys, and focus on the job trends. So this graph basically talks about the number of job seekers for big data domain percentage-wise. So as you can see in 2014, it was somewhere around 0.020%, but now it has increased and it is continuously rising as well. So this is the job trend, guys, and let me tell you the reason for this. Basically, data is rising exponentially. We have discussed that, right? So companies need people who can analyze that big data and can help their business to grow. Now there are certain stats that I'm going to share with you. So by 2018, there will be 21 billion internet connected products. And companies spent over $31 billion in big data projects and tools. In 2013, they did that. And big data spending is expected to reach $114 billion in 2018. So these are few stats that will actually tell you how big data market is rising right now. So this is the correct time in order to start your training and do wonders in your life basically. So let's move forward, guys, and focus on the big data and Hadoop training provided by Edureka. So this is the structured training, guys, in which we discuss all the components of Hadoop, and then finally we have projects as well. So let me tell you about the structure of the course, how it looks like. So the first module will be your big data and Hadoop concepts, your basics. Then we'll talk about HDFS and MapReduce frameworks. Then we'll understand the architecture of Hadoop and we'll set up the Hadoop cluster. Then we'll understand how to exactly write MapReduce programs and learn data loading techniques. Then we'll perform some analysis using Pig and Hive. So we use Pig in this session as well, but we are going to discuss in detail about Pig commands, similarly for Hive as well. So like Pig Latin, Hive uses a Hive query language. Then comes HBase and NoSQL concepts. Now basically what is HBase? It is nothing but a NoSQL database present on top of HDFS. Then we need to understand how to schedule jobs using Oozie. Then we'll understand how to implement the best practices for Hadoop development. And we'll also focus on Spark a bit. We'll understand its ecosystem and we'll learn how to work in RDD in Spark. Finally, we'll have some projects. So you need to execute at least one project in order to get the certificate. And on the basis of your project, on the basis of how you have done your project, there'll be grades given in your certificate. It is not mandatory that you need to do only one. You can request for more projects as well. But for certificate, you need to finish at least one project. Let us move forward and see what are the various projects that will be a part of this course. So there are certain projects like analyze the social bookmarking sites, and the industry will be social media. Similarly, we'll have customer complaint analysis, industry will be retail. So for these things, all these projects that I'm discussing right now, there'll be data set given to you along with the problem statement. You need to come out with the best possible solution. So it's not like you need to use all the Hadoop tools that are there. So all the tools that are there in Hadoop framework, you don't need to use all of them. So you need to make sure that whatever tools that you're using are going to give you a perfect solution and an efficient solution as well. Similarly, we'll have around 6 projects. So you can choose any one of them and you can request for multiple projects as well. Airline data analysis, industries aviation, analyze loan data set, analyze movie ratings. All these things will be a part of the course. If you have any questions, any doubts till now, you can ask me. Any questions, guys, please write it down in your chat box. I'll be happy to help you. Any questions, guys? So Emilia has a question. She's asking only these many projects will be a part of this course. Emilia, these are only 6 projects that I've listed here. There are many more projects which you can take up and finish it off and get your certificate as well. So these are a few examples that I've given you here, and you'll be provided with the data set which will be huge in size, let me tell you that. And you have to perform certain analysis and there'll be a problem statement obviously given to you. So basically in Edureka, our major focus is hands-on. So this project is very, very important in the end in order to get the certificate. I hope this answers your question, Emilia. Fine. So Siddharth has a question. He's asking, what if I miss a class? Siddharth, what happens in Edureka, you have the flexibility to change your batch anytime that you want. Apart from that, even if you have done the course and you have finished the project, you have done everything, you have got the certificate as well, and say after 10 years you want to take up the course again, you can do that free of cost. So you can take the classes multiple number of times, the live classes. So whatever access that Edureka provides you, it is there for your lifetime. I hope this answers your question, Siddharth. So even if you miss a class, you can always reschedule your batch. You can change to the next batch. All right, so he's happy about it. So any more questions, guys, please be free to ask me any questions. Ayushi says, amazing session. Thank you, Ayushi, for those kind words. All right, fine, guys. So what I'll do, I'll move forward and give you a brief summary of what all things we have discussed. So first we understood what exactly is big data and what are its various growth drivers. I mean, why is it increasing so rapidly? Then we understood big data in different domains. We saw how you can use it in retail. We saw how you can use it in healthcare. We saw how you can use it in education, government, and various other departments. Then we saw various problems with big data and how Hadoop solves those problems. We also discussed about various components of Hadoop like HDFS, Yarn, MapReduce, Pig, all those things. I basically gave you a brief introduction about the whole Hadoop ecosystem. Then we focused on a case study of Aadhar card. We had 4 problem statements which we solved by using Pig. Then we focused on the big data and Hadoop training provided by Edureka. We saw various projects that will be a part of this course. That's it, guys, for today's session. Thank you guys for attending today's session. This video will be uploaded into your LMS so you can go through it. If you have any questions or doubts, you can bring it in the next class, or you can ask our 24/7 support team as well. Thank you and have a great day.
I hope you enjoyed listening to this video. Please be kind enough to like it, and you can comment any of your doubts and queries, and we will reply to them at the earliest. Do look out for more videos in our playlist and subscribe to our Edureka channel to learn more. Happy learning!